All right, we are moving on in the Pythagorean theorem to now just solving some word problems. So it seems like there's always, in every standardized test I've seen, there's always a ladder problem. So this particular problem says the bottom of a ladder must be placed 3 feet from a wall. Okay, I'm not a very good artist, but this is going to be my wall. Um, Here, I'll try to make some cute like bricks in it or something. I don't know. Okay, this is a terrible job and I'm wasting time. Sorry. Okay, fine. Brick wall. Got it. Okay. The bottom of a ladder. Here's your ladder. It must be placed 3 feet from the wall. So here's the 3 feet, and here's where your ladder is going to start. The ladder is 10 feet long. So here's your ladder. It's obviously leaning against the wall. So again, terrible artwork here. Whatever. This is your ladder. Okay, I'm sure yours looks a lot better than mine. So it's 3 feet from the wall, and it says the ladder is 10 feet long. So here's my ladder. It is 10 feet long. And the question is, how far, it says about, but sorry, that's a typo. That should have been above. How far above the ground does the ladder reach? So I want to know, how tall is this right here? So from the ground to the height that the ladder touches the wall, how tall is this part? So the question is, if you know that a ladder leaned against a wall forms a right triangle with the wall, here's your right angle, this is a triangle, you have to know, you have to put it into your own mind that, oh my gosh, this is a right triangle, therefore I should use the Pythagorean theorem. And again, the Pythagorean theorem, which you should definitely have memorized by now, is a squared plus b squared equals c squared. And the reason you can use this is because that only works in finding sides of a triangle if the triangle is a right triangle. So we know the longest side. We know the diagonal that's across from the right angle, which is the hypotenuse, which would be the c. That is 10. It almost looks like that's part of the number. 10. You also know the bottom leg length, it has to be 3 feet from the wall. So you know one of our leg lengths. What we're missing is the other leg length, how far up it reaches. So I'm going to call this one B. So I'm going to subtract, because since we have our hypotenuse, we have our longest length. So I'm going to make 10 squared subtracted 3 squared to equal our B, which is the height of how far up the ladder hits at the wall. So 10 squared is 100. 3 squared is 9. 100 minus 9 is 81, which I really like because that's going to come out evenly. Because I know that the square root of 81 is 9. But if you're not sure, put it in your calculator and check. 9 times 9 is 81. So 9, I think they said feet, is the distance from here to here. All right, the next word problem says a soccer field, okay, we're just going to say that's a soccer field, is 100 meters wide by 130 meters long. So 130 meters long by 100 meters wide. Okay, then it says Coach Smith asks his players to run from one corner to the other corner across the field diagonally. What is that distance? Okay, again, you are solving a right triangle. If you don't look at the other side of the field, you have a right triangle here. So you have a 130 leg and a 100 leg. And what you're trying to find is the hypotenuse. So since we have both legs, we are going to add. So we would do 130 squared plus 100 squared, and that's going to equal our hypotenuse squared. 130 squared is big. It's 16,900. All right, 100 squared is 10,000. Oh, yeah, we could have done that. 10,000, sorry. So when you add those two together, 16,900, you get 26,900 feet. And that, of course, is what c squared equals. So we need to square root it to find just the diagonal distance. The square root of 26,900 feet is about 164, and that's just going to stay 0. So about, Coach Smith asked his players to run about 164 meters. All right, let's look at the next page. So this is the last one that I'm going to do with you before I want you to try just a couple on your own of word problems. This one is a baseball question. It says a baseball diamond. I think even though it's a diamond, it's technically just, okay, this is not going to be a very good picture. I think even though it's a diamond, it's technically like a square, isn't it? I don't know. Like on its side, whatever. Okay, a baseball diamond. Just sketch it. I'm sure it's better than mine. Is a square. That's what I meant. See, it's supposed to be a square. It's just turned. That is 90 feet on each side. So it's 90 feet on this side, 90 feet, 90 feet, 90 feet. Okay, great. It's 90 there and there also. But I just want to know what the distance is that a catcher, and by the way, this is where a catcher stands. A catcher has to throw a ball from home base. So this is home, all the way to second base. So obviously this is first, second, third, home. So if he has to throw it from home all the way up here to second, that's the distance we're trying to figure out. So if you turn it and you know that it is just a square, which it says that, you can cover up half of it and look at what we're actually dealing with. We're dealing with a right triangle where this is 90 and it said all the distances are 90 and this is also 90. So we have a 90, 90, and a question mark for our hypotenuse. So the two 90s are the two leg lengths, and we're just trying to find the distance from the hypotenuse all the way across. So we're going to add because we have the two leg lengths. So 90 squared plus 90 squared would be equal to our hypotenuse squared, the long side. So what's 90 squared? 81, 8100 plus 8100. If you add 90 squared is 8100. Yeah, 8100 plus 8100, it is 16,200. And then we're just going to square root both sides. The distance across square root of 16,200 is about 127 point, that's going to bump it up to 3. So 127.3 about, and that is feet. Okay, I would like for you to pause the video and try the next just two. There are 2 word problems on your own, and then push play and check and make sure you did it correctly. Okay, if you're checking with me or if you're just working it out with me, this David leaves his house to go to school exactly reminds me of one that we did in a different lesson. So you should probably know how to do this. He's going to walk west and then north. So if this is him walking, it says he walks 200 meters west, and then he turns and goes 125 meters north. Okay, and then he stops right there. So when he gets to school, this is school. I'm not going to put bars on it this time. So this is just HMS, not jail. So he gets to school. When he gets to school, how far is he away from home? This is literally the exact same problem. So what we're wondering is how far is the diagonal route, which is the C, the hypotenuse. So since we have the 2 leg lengths, we're going to be adding. So we're going to do 200 squared plus 125 squared, and that's going to equal the length of the hypotenuse squared. So 200 squared is 4,000. Actually, I should just do this in here just to make sure. 40,000, yep, that's right. 2 zeros doubled, 2 and 2. Plus 125 squared is 15,625. 15,625. Okay, and then we're going to add these two together. So 15,625 plus 40,000 equals 55,625. 55,625. And that is what c squared equals. So we are going to square root that number to get a more approximate value. 55,625 is about 235.8. So 235.8, and he's talking about meters. That's how far his diagonal distance is away from school. Okay, number 2 says that a park is in the shape of a rectangle. So this kind of reminds me of the soccer problem. So draw your rectangle. It's always good to draw out what you're doing. It's a rectangle that's 8 miles long by 6 miles wide. How much shorter is it? Oh my gosh, there's another typo. If you, not your, if you, how much shorter is it if you walk? Oh wow, that's really a typo. Sorry. It's supposed to say how much shorter is it if you walk diagonally across the park instead of walking 8 plus 6, the two sides of it. So what I want to know is what is the C side? And not just what is it, but how much shorter is it to go this direction than all the way around the 8 plus 6. So since these are the two legs of my right triangle, I'm going to be adding. So let's do 8 squared plus 6 squared equals C squared. So 8 squared is 64, 6 squared is 36, 64 plus 36 is 100. That's going to be easy to calculate because I know, and so do you hopefully, that the square root of 100 is exactly 10. So that means that this distance is 10. So 10 is not the answer. It wants to know how much shorter it is if you walk this 10, which is diagonal, rather than going the 8 plus 6. So let's figure out what 8 plus 6 is, which is 14. So how much shorter is it if you go the diagonal 10 versus the 14 all the way around? It is 4 miles shorter.